Integrating techniques with trig functions is really exciting. If you already know the integral of sine of u is minus cosine of u plus c, and the integral of cosine of u is sine of u plus c. But you need to learn how to find the integral of tan u du is minus log of cosine plus c, and the integral of cotangent of u du is a log of the absolute value of sine plus c. And for the integral of secant of u, that's the log of the absolute value of secant plus tangent of u plus c, while the integral of cosecant of u du is minus the log of cosecant plus cotangent. Let's see if we can show that what the integral of tan is. If I break tangent up into sine over cosine, I see I have a u substitution. If I let cosine of x equal u, then du is minus sine of x dx. So now if minus sine of x dx is du, then I can multiply this through by -1. So this becomes minus the integral of du over u. So this is minus the natural log of the absolute value of u plus c. So it's minus the log of the absolute value of cosine of x plus c. Now let's look at the integral of secant. This one, we have to do a little bit of a trick. Let's integrate. Now I'm going to put secant of x in the numerator, and I'm going to multiply by secant of x plus tangent of x divided by secant of x plus tangent of x. This is just a trick. I'm multiplying through by 1 dx. Now let me distribute this across. This is the integral of secant squared x plus secant tangent, all divided by secant of x plus tangent of x dx. Now, at this point in time, I can let u equal secant of x plus tangent of x, and then du is, well, the derivative of secant is secant tangent, and the derivative of tangent is secant squared. And this is all multiplied through by dx. So this falls right into line as the integral of du divided by u. So the solution is it's the natural log of the absolute value of u plus c, or the natural log of the absolute value of secant x plus tangent x plus c. Now what if I have something like the integral from 0 to pi over 4 of 1 plus tan squared x? I can use a trig identity. I know secant squared x is 1 plus tan squared x. So this becomes the integral from 0 to pi over 4 of the square root of secant squared x dx. Now, on 0 to pi over 4, secant is positive, so this is just the integral from 0 to pi over 4 of secant x dx. Now we know the integral of secant x dx is the natural log of the absolute value of the secant of x plus tangent of x, and it is evaluated between 0 and pi over 4. Now it's just a matter of plugging in. This is the natural log of the absolute value of secant of pi over 4 plus tangent of pi over 4 minus the log of the absolute value of secant of 0 plus tan 0. So we wind up with the natural log of the square root of 2 plus 1 minus the natural log of 1, which is 0. I can find this exactly, or approximately actually, as 0.881. Now, what if I wanted to find the average value of a function using trig functions? Everything's still the same. The average value of tan x on 0 to pi over 4 is, now you can write the word average value, equals 1 over b minus a, the integral from a to b, f of x dx. And I still want you to write this formula down. So it's 1 over pi over 4 minus 0 times the integral from 0 to pi over 4 of f of x is tan x dx. So 1 over pi over 4 minus 0 is the same thing as 4 over pi. The integral of tangent is minus the log of the absolute value of cosine of x, evaluated at 0 and pi over 4. So I'm going to factor this out, minus 4 over pi, and this becomes the natural log of the cosine of pi over 4 minus the natural log of the cosine of 0. And I've dropped the absolute values because it's always positive there. So it's minus 4 over pi times the natural log of the cosine of pi over 4, which is the natural log of the square root of 2 over 2, minus the natural log, cosine of 0 is 1. So this term right here is 0. So it's minus 4 over pi natural log square root of 2 over 2. And I could get an approximate answer of 0.441.